All right, first we have to find the domain and range of cosine of x. All right, so you just plug it into your calculator. So we have cosine of x here. We can see that the domain is all real numbers, and the range is from -1 to 1. So the domain for this is x is all real numbers, and then the range is just -1 to 1. You can also write this as this way. Not sure which way he wants it. The second one says h, which is tangent of x. All right, so tangent of x. All right, so tangent of x. So this is a little bit trickier. So you can see, like, tangent, it goes all the way up, right? So you know it's gonna be from your range is -infinity to infinity, but this has an asymptote. Okay. So our range is -infinity to infinity, or just -infinity to infinity. So now you have to remember what tangent is. Tangent is sine over cosine. So whenever cosine is equal to 0, you're going to get does not exist. So you need to find a place where you have to find all of them where cosine is not equal to 0. Where cosine is not equal to 0. So first let's find when is cosine equal to 0. Okay, well, cosine is equal to 0 here, which is just pi over 2. Right? So that's pi over 2. Okay, so at pi over 2, it's 0. And see, we're going to add another pi. That gives you this 0. Then we add another pi. So let's make this 2 pi. It gives you this 0 here. So pretty much we're just keep adding pi to pi over 2. And that is when that is not cannot equal to 0. So cosine is equal to 0 when the angle is at pi over 2 plus a certain amount of k, right? So for this being, we have to say that x is all real numbers except except when x is equal to pi over 2 plus k pi, and k is an integer, positive or negative, it doesn't matter. Okay, so it's every other number except for pi over 2 plus pi plus k pi. Okay, and your range is -infinity to infinity. Alright, so let's look at the next one, which I lost it. Which will be p. P is a sine inverse. All right, so sine inverse. So sine inverse. So domain and range again. So let's look at the graph for sine inverse. So sine inverse. This is the graph for sine inverse. All right. So you can tell. So our sine. So remember, inverses is pretty much you have to flip sine and cosine. So the domain and range for sine, the domain is all real numbers, right? But your range is from -1 to 1. So now for sine inverse is going to change. Our domain is from -1 to 1, but our range cannot be all real numbers. My bad. Our range cannot be all real numbers because our sine wave, remember, keeps going up and down, up and down, up and down, right? So this is going to be the same thing, but it's going to keep going this way over and over and over and over again. Okay. So we need to pretty much find out when is sine equal to 1 and when is sine equal to negative 1. Okay, now that is going to give us our values. So if you look on your graph, sine, come on, it's a little bit. Sine is equal to 0 at where? At, let's see, at pi over 2. Let's see, is that right? Yeah, at pi over 2, and then is also at negative pi over 2. Okay, so now our domain, our range for this one is going to be at negative pi over 2, y, to pi over 2. Now any other value for this is not going to, it is going to exist, but not really. Because if we want something bigger, we just have to keep subtracting by 2 pi to get us anywhere between pi over 2. All right, so they want us to get sine inverse of 3 pi. You have to subtract 2 pi from there, and then take the sine inverse of that number. Okay, so just think about the sine wave and just turning it sideways. I mean, yeah, it's reflecting across the y is equal to x line, and you'll get that. All right, the next one is q cosine inverse. So cosine inverse is kind of going to be the same thing. Our domain again is still going to be, because cosine, the domain for cosine is all real numbers, and our range is -1 to 1, right? So our domain is still going to be -1 to 1, but our range is going to be different. Our range is going to be when did cosine give us -1 and 1? Okay, so when did that give us -1 and 1? So we look at cosine inverse. This is cosine inverse. Oops, my bad. Our range is from, wait, 0? Yeah, my bad. Our range is from 0. Our domain is -1 to 1. Then our range is from 0 to 2 pi. That's really it. It's really just 2 pi. Okay? Or just pi. This is just at pi. Okay? So when does it give us 0? And when does it give us 1? Alright? So our domain is -1 and 1. So we want to know when that gave us -1 and 1. So it gave us 1 at 0. Stupid thing. Okay? So it gave us 1 at 0, and then it became this at pi. Okay? So our range is from 0 to pi, and our domain is -1 to 1. The next one is r, which is tangent inverse. So let's look at tangent inverse. Tangent inverse, now for this case, our domain is all real numbers, because remember they switch from tangent, it's going to switch over. So tangent inverse. Our domain wasn't all real numbers, our range was, so now this becomes, our range is, there's our old domain, or the domain for regular tangent, which is all real numbers. Okay, now our range is going to be different. So our range is going to be, when did it give us our first asymptote, right? So the asymptotes were at pi over 2, right? So let's graph pi over 2. Okay, so that's our asymptote because pi over 2, and then also is going to be negative pi. Oops. Negative pi over 2. Okay, even though it never reaches it, that is going to be our asymptote. So, dude, come on, get away. Why do you do this? Alright, so then it's going to be negative pi over 2 and just pi over 2. Okay? And the last one is f, is secant of x. So let's graph secant of x. So that is secant of x. Now secant of x is a little bit different. Since it is 1 over cosine, we need to find out when. Alright, so you can tell is 1 all the way up to infinity, and also -1 to infinity is our range. Okay, that is our range. So let's go ahead and fill out our range. So secant, we know our range is from -1 to infinity and 1 to infinity. Right? Okay. And then, oops, my bad. Oh, really? You can do this to me? Alright. Was from here now our domain. Let's look at our graph. Our domain grows in spurts, right? So it's the same thing. So you have to remember that secant is 1 over cosine, right? So our domain is going to be all real numbers except when cosine is equal to 0, right? So using our tangent, we know our domain is all real numbers, right? It's gonna share the same domain as tangent, except for the multiples of. Oh, dude, come on. Sorry, man. This technology's making me mad. Alright, it's all real numbers except the multiples of pi over 2 plus no wait. Let's look at the graph one more time. Let's look at the graph of tangent together. Okay. So our domain only exists, yeah, it only exists between here and here. So yeah, it only exists between those 2 points. So it is all real numbers except for pi is equal to that. Cool. Alright, and that is it. Again, my bad for the video. No idea why it's messing up so much. But again, you can use your calculators. Go to desmos.com. I'll send you a link right now of a table a PDF that has all this stuff already on there. So you can just try to memorize this stuff. All right.